The pathway of opioid addiction recovery is incredibly challenging. In prior videos, I explained how opioid addiction is a biochemical phenomenon. Getting unaddicted to opioids isn't simply a matter of someone stopping their use of synthetic opioids. Someone who has an opioid use disorder doesn't produce sufficient levels of natural opioids like endorphins to simply feel okay, both mentally and physically. They can experience terrible withdrawal symptoms. But why is this the case? I mean, why can't someone just stop using opioids and get back to regular life? And if the withdrawal symptoms are so devastating, what kind of hope is there for someone with an opioid use disorder? Well, let's take a look. In this video, we're looking deeper into the cell biology and biochemistry of opioid addiction and recovery. But first, a caveat. Brain biochemistry is incredibly complicated, and in many cases, including that of addiction, certain biochemical and biomolecular pathways aren't even really fully understood. So what I'll go over in this video is just one of the ways that it seems like addiction and recovery work at the level of the neuron. All right, let's dive in. First, a quick recap. Natural opioids, such as endorphins, are produced in the pituitary gland at the base of the brain. They ultimately end up interacting with neurons in a special part of the brain called the ventral tegmental area. Those neurons normally produce a molecule called gamma-aminobutyric acid, or GABA for short. These GABA molecules then interact with neighboring dopamine-producing neurons and inhibit their ability to produce and release dopamine. But when opioids bind with the opioid receptors on those GABA-producing neurons, GABA production is halted, allowing dopamine release to occur in those neighboring dopamine-producing neurons. Key to this process are those opioid receptor proteins like OPRM1. The more opioid molecules that opioid receptors interact with over a short period of time, the more that GABA production gets inhibited within those GABA-producing neurons, and the greater the subsequent release of dopamine from the dopamine-producing neurons. Large doses of synthetic opioids, like fentanyl or oxycodone, are incredibly effective in doing this. But what happens when these synthetic opioids are taken in large doses over long periods of time? Well, in that situation, the opioid receptors become engaged over and over and over and over in really quick succession, and GABA is continually suppressed. Now, if you're a GABA-producing neuron, the continual suppression of GABA isn't good for business. In that situation, there are molecular mechanisms within GABA-producing neurons that kick in to help maintain GABA production. For example, there is some evidence to suggest that opioid receptor genes, like the OPRM1 gene, get down-regulated or silenced. This just means that transcription or translation are interfered with, so that production of the OPRM1 opioid receptors is temporarily halted. Over time, this would lead to fewer and fewer OPRM1 receptors on those GABA-producing neurons. There's other evidence to suggest that perhaps the OPRM1 receptor proteins are in fact made, but that cellular processes interfere with those receptors being fully integrated into the neuron cell membrane. There are still other suggestions that perhaps the opioid receptor proteins are still made and integrated into the membranes of neurons, but that they're inhibited from the inside of those GABA-producing neurons so that they can't transmit a signal as effectively to halt GABA production. In any case, with chronic opioid use, the fewer and fewer fully functioning opioid receptor proteins on those GABA-producing neurons means that it becomes harder and harder to suppress GABA, making opioid-associated dopamine responses more difficult to achieve. Because of this reduced capacity of the opioid receptors, if you have an opioid use disorder, you now need to take larger and larger doses of synthetic opioids in order to achieve the same high that you previously experienced. Furthermore, when synthetic opioid intake is shut off altogether, you're left with a set of damaged and depleted OPRM1 receptor proteins, which themselves are now unable to get enough of a signal from your own naturally produced endorphin opioids to stimulate the dopamine production that you need. So you're stuck in this hellish feedback loop. You can't stop taking high doses of synthetic opioids because you need to interrupt GABA production in order to produce the right amount of dopamine to survive and feel good. But if you continue to take high doses of synthetic opioids, it could even further diminish the capacity of the opioid receptors on those GABA-producing neurons, resulting in even higher demands for opioid intake. So what can you do? Well, you may recall that addiction involves both an environmental and a biochemical component. Successful recovery, therefore, also involves both an environmental component and a biochemical component. On the environmental side, new behaviors are typically needed to help facilitate recovery. Remember, fulfilling and rewarding experiences can have a very real chemical impact on us. So you would need to absolutely maximize the amount of natural opioids, like endorphins, that your brain produces. Experiences that could result in endorphin production might be fulfilling work activities, new hobbies, sports and exercise, social interactions, sex, adventure, and so on. Any behavior that stimulates a feeling of satisfaction, connection, accomplishment, excitement, all of those things will help your brain biochemistry in the enterprise of endorphin and dopamine production. On a biochemical level, the key here is to continue to suppress GABA production, but not as fully as what happens with drugs like fentanyl or oxycodone. To accomplish this, different synthetic opioids are used. Methadone is a good example. It isn't as fast acting as fentanyl or oxycodone. It does bind to the opioid receptors, triggering a measure of GABA suppression, but then it kind of hangs on for a little while onto that receptor before exiting and allowing another methadone opioid molecule to come in and take its place. Because it is much more inefficient in its interactions with the opioid receptor protein, the highs, or the euphoria that it stimulates, are lower. And because methadone has a much longer half-life than fentanyl or oxycodone, it helps keep that methadone around in your system longer, resulting in longer drug-associated upswings. This slower and more inefficient process that methadone brings about means that eventually, over weeks, months, sometimes even years, your GABA-producing neurons start to slowly build back a fuller complement of fully functioning OPRM1 receptors, helping you on your journey down a pathway to recovery. If you or someone that you care about has an opioid use disorder, you can always call the National Substance Abuse Hotline at 1-800-662-HELP. That's 1-800-662-4357. They have people answering phones 24 hours a day, 7 days a week. They provide treatment referrals and resources to help aid in recovery. I'll leave that number on the screen as the credits roll, and I'll see you next time.